Siemens Energy is present across the energy value chain, and our broad portfolio is built into three core pillars. So we are present into power generation segment of it. We are also present very much into the transmission side of it. And then the third pillar is about usage of energy into various industries, wherein we have our vast portfolio in terms of improving the energy efficiencies of existing energy assets, and also electrification of power industrial processes. And then third one and most important one is into the deep decarbonization, which is green hydrogen. And happy to share that we are operating in more than 90 countries. That's where we have a broad customer base, and through which we are getting a lot of learnings and insights as well. Moving on to the next slide. So here, basically, we would like to just share how we are contributing to the green hydrogen economy through industrial scale PEM electrolyzers. And before developing the industrial scale PEM electrolyzer, we have to go to the phase wise manner, right? Not only on the development side, but also how we are producing those electrolyzer, and then finally we are deploying it on the ground and gaining experience from the ground. So I will be mostly center my discussion and share the learnings from the three phases: development, production of electrolyzer, and also the deployment of electrolyzer on the scale. And that is how you are able to get the, let's say, scalable technology along with the safety features built into it, and maintain the consistency and the consistent performance out of these electrolyzers. So first, let me put my focus on to the development side of it. So if you go to the next slide, please. Next slide, please. So here we would like to share that previous slide, please. Um, we would like to share that we have been developing PEM electrolyzers since 1995, and it has been a couple of decades. It took some time that to develop the electrolyzer technology and bring it from the lab scale to the commercial scale. And during this time, we have been able to, let's say, also secure a number of patents, broad set of patents, and also bring the technology to the TRL readiness level of 9, which is which kind of indicate to the industry that we have a mature technology available for the commercial scale. And during this time, we were also able to build in or embed some of the key features into the electrolyzer design, which helps not only on the scalability side, but also the safety of the technology. Because at the end of the day, we all understand that green hydrogen or molecule is very, very promising in the decarbonization, but it is also, let's say, considered as a molecule which need to be handled in a safe manner. So if you see on the right hand side, we have a couple of features that we have been built into the electrolyzer. One of them is that how do we take care of the current density so that we ensure that not only the efficiency is there, but also the thermal loading on the electrolyzer as well. And then second one and most important one I would like to spend some time over here is that how do we ensure that the longevity of the electrolyzer, and that is what we are doing through the two-sided cooling of the membrane. What does that mean is that when your electrolyzer is running, you are producing gas on the both side of the membrane, oxygen and hydrogen, and we have to ensure that when your current density is there, of course it is the loaded with the thermal or heating happens, and then we need to make sure that how do we are taking care of this thermal load through the cooling of the both side of the membrane. It's basically an essential feature for the longevity of the membrane of the electrolyzer. Third one is very, very important on the atmospheric pressure side, because this helps to ensure, and it's a safety feature. It helps to ensure that we have minimum crossover from the hydrogen to the oxygen side. And we all understand that when hydrogen get mixed with oxygen and it reaches certain percentage, then of course it could be an explosive mixture as well. So similarly, we have other features as well, non-differential pressure as well as low operation temperature feature. And then last one is also the vertical cell design. Now, what does that mean is we ensure that our cell is vertical to ensure that we do not have any untrapped gas into the membrane. And also the membrane cell design is the largest membrane cell that we have designed into the PEM electrolyzer. Overall, what we want to say that there are some unique features that we have able to build over the period of time and include into our technology, which ensures not only the scalability but also the safety of the technology while delivering the performance on a consistent basis. And once you have your development side is kind of sorted with the right kind of features, then we get into the manufacturing or the putting all those memories into this step. Maybe if you go to the next slide. So here what we have done is after sorting the development phase, we have put together our electrolyzer as a system of 17.5 megawatt design, which is based on a modularity concept. When I say modularity concept, it means there are, let's say, 24 stacks that had been put together to operate optimally. And then based on the customer need or market needs, this 17.5 megawatt of electrolyzer can be scaled up in the multiple of 17.5 megawatt. So you can have 17.5 megawatt system, then of course 35, 50 megawatt, 70 megawatt, and 100 megawatt design. And then probably I'll show it to you also in a moment that how this concept is helping in the easier transport of electrolyzer, but also reducing the commissioning site and the installation time. But more than that, I would like to share two important aspects over here that we are learning from the customer from the global customer base is that when our developers or the investor they are putting a business case, it's very important for them to consider two parameters. One is how much energy is going to be consumed by electrolyzer plant, and that is nothing but a cost for the developers. Uh, and then second important parameter is the hydrogen production or net hydrogen production, which will act as a revenue. So it's a usable hydrogen that goes to the end customer and then translate into the revenue. What we have found over the period of time that it is becoming even more challenging in order to have the accurate consumption of electricity and accurate measure of hydrogen that translate into revenue. All in all, there is still, uh, let's say, a gap as far as the standardization of performance of electrolyzer is concerned. In order to bring some light on it, what we have done as a part of Siemens Energy, we have been able to put a white paper which transparently share how you can, let's say, calculate the performance of the electrolyzers considering the consumption as well as the use of as well as the actual production of hydrogen. Because at the end of the day, when you are running your electrolyzer plant, you also notice that at various phases there is a loss of green hydrogen that you cannot use. Of course, it is being produced by electrolyzer, but it is not cannot be put into the usage. So I will encourage everyone that to download this white paper, and it is our kind of attempt to, let's say, advocate for a standardized approach uh, 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 to the industry. So this was, let's say, more onto the design and development phase. Now, obviously, you have to produce these electrolyzer and at a larger or mass scales. So happy to share that in 2023 we were able to inaugurate our Gigawatt factory in Berlin, and that's where we are doing the mass production of our stacks. And would like to also share some of the activities we are doing in this multi-gigawatt factory that ensures that we have consistent quality of our stacks. So I think if you go to the next slide, number one is this factory is based on Industry 4.0. What does that mean is it is, let's say, mostly autonomous production facility, which ensures that we are able to fast track and optimize production with the consistency of the quality. Number two is in this factory we are also taking care of or have a complete control on the membrane electrode assembly. We call it ME, which is nothing but how do we ensure or condition the membrane for the optimum performance? So we do our own layering of the electrodes on the membrane. And then third and important piece of element is, if you go to the next slide, please, uh, that the further next slide, that we are also, once the stack is produced, we are also kind of doing the thorough testing of these stacks by filling up with the water, providing the power, and ensuring that it is running and producing the electrolyzer, producing the green hydrogen at an optimum purity, and the production rate. So obviously we have been, as I said, we are gaining a lot of experience from the ground while deploying these large scale electrolyzers at a scale. And if you really see that we are, let's say, deploying the electrolyzer on a very progressive manner. We really started with deploying this electrolyzer at a single digit megawatt range, starting in 2019. And then slowly we scaled up from single digit to double digit megawatt range. And happy to share that the 50 megawatt and 54 megawatt, they are fully commissioned and are running, let's say, from 2025. But also we had earlier projects which were running from 2019 as well. So overall, what we have done is we have got a lot of data points from the market, and overall, let's say, more than 300,000 equivalent operating hours of experience we have seen in these electrolyzers. And through this, we are also able to see that how it is being performing, and happy to share that they are running absolutely fine, and which kind of give us the confidence and the signal to the industry as well that technology at a larger scale is ready to be deployed. Apart from double digit megawatt range, we also see there are some other projects which are under implementation phase, which we have been able to acquire over the period of time. So some of the projects are, let's say, from with the Air Liquide, 200 megawatt. Then we had with EWE these 280 megawatt, and then 100 megawatt, and then further 200 megawatt projects. So there are handful of projects that we are seeing that are happening in the Europe, and where we are kind of putting our technology into the test to see how they are performing. And of course, this gives us a lot of confidence that the technology is working. And also one topic maybe I would like to share over here is that, based on the let's say deployment of electrolyzer on the ground, based on the production facility, based on the serviceability as well as the safety of the electrolyzer, these PEM electrolyzer are technology ready, have achieved the technology readiness level of 9, which is the maximum maturity of the technology, and it shows that it is ready to be commercially deployed. Next slide, please. And then we would also like to share that, of course, once you have installed these electrolyzer, you need to do the service of this electrolyzer as well. And we have a huge setup of the service infrastructure, and wherein we do service on a various level in order to ensure the reliability and availability of these electrolyzers. And as I was referring earlier, that we have been able to gain experience from these running electrolyzers, and we have accumulated around more than 300,000 operating hours from these electrolyzers. And of course, we also would like to share that the longest running stack we have right now, continuously running stack right now, of more than 40,000 equivalent operating hours. And then I would like to come to the, let's say, one important element as well. If you go to the next slide, that of course electrolyzer is a central piece of any hydrogen plant. But if you really look at the value chain of green hydrogen, there is a lot of things that we need to take care on the upstream side of electrolyzer as well as downstream of the electrolyzer. So when I say upstream of the electrolyzer, what we have seen is that we need to be very, very careful and let's say, do the planning at the early of the stage as far as the grid connectivity is concerned. So grid connectivity is an important element in this electrolyzer plants. And then second thing is, if you look at the downstream side, of course, once you have produced the hydrogen, you have to ensure that how do we put it to use, and then that's where the compressor and other auxiliary systems comes into the play, and that is also being kind of provided from the house of Siemens Energy. And then if you like to use this green hydrogen and create other value added products like ammonia, um, methanol, etc., then of course we are able to serve this power to X complete value chain along with our partners. And then now coming back to the some of the references that I would like to share with you. If you go to the next slide, please. Yeah, so one of this, let's say a picture from the running plant. So this plant is operating in Denmark. Uh, 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 Plant name is Gaso, and this is the first, let's say, large-scale e-methanol plant in Europe, wherein Siemens is providing three of its 17.5 megawatt electrolyzers. So its total power demand is around 50 megawatt. And in this picture, you can see in the front, there are three buildings. These buildings are electrolyzer buildings. And then in the bottom, you can see this is an another the balance of plant layout. And of course this plant is drawing power from majorly from the solar, and then of course there is an arrangement for the grid supply as well. So this is one of the project which has been already operationalized, of course, in Denmark. And then we have another project more or less similar, similar scale. If you, the next slide please. Yeah, so this is here the application. The previous one had the application of methanol, and this one is basically application is for the chemical plant. So with BASF, we have been able to, let's say, jointly put together this plant, and this is also a scale of around 50 megawatt scale. And we have this plant running in Germany, up and running. With the real pictures from those sites. If you go to the next, yes. And there is another project, of course, then at a bigger scale. This is 210 megawatt scale size. Of course, this is currently in an implementation phase, and you can see in the background again. These are the real pictures. In the background, you can see the two blocks of 100 megawatt. And when I say 100 megawatt, then of course it again shows the scalability in terms of you can put six 17.5 megawatt electrolyzers to make a one block of 100 megawatt. And then based on how much you want to scale, you can put these 100 megawatt block in series. Okay, going to the next slide, please. And then again, this is the another project which we have been recently awarded of 100 megawatt. And again, this is from Germany, uh, wherein obviously along with the award of project, we also have a 10 years of service contract with them as well. And of course, it is in the implementation phase. Next slide. And this was the another even a bigger scale. This is for 280 megawatt with with EWE. And here also, if you see, we have a 10-year service contract with them. And this is also under implementation stage at this point of time. Okay. Next slide, please. Okay. I think this is where we have our reference list. So just overall to summarize, the our contribution to, let's say, green hydrogen economy has been through um, tried and tested large scale PEM electrolyzers. And I just wanted to share or give a quick view today what are the critical element during the development stage that we have been able to embed into the electrolyzer design, and also what we are doing on the production side of the electrolyzer through our gigawatt factory, and then also how we are getting those learning and validating this technology by deploying these electrolyzer at a larger scale.